So once again, welcome to my YouTube channel whose name is Knowledge Entertainment, and as promised in the previous video, I'll continue with more and more questions on trigonometry, and this time a little bit difficult questions in this video and the coming 2 or 3 more videos. I'm taking more and more questions from the competitive examinations like IIT, JEE and other entrance examinations for engineering. So the first question what I'm taking today is, I'm having the statement here. If question is, if theta is divided into two parts such that tangent of one part is m times the tangent of other part if phi is their difference, if phi is their difference, show that sin theta is equal to m plus 1 over m minus 1 sin phi. So this is the statement of the question. There is an angle theta and it is divided into two parts, say x and y, such that the ratio of their tangents, that means tan x divided by tan y, is m is to 1. So tan of one part is m times the tan of the other part. And phi is their difference, that means phi is x minus y. And we have to show that sin theta is equal to m plus 1 upon m minus 1 sin phi. This is the final result what we are to arrive at. So I am starting with the proof. Let the two parts be x and y. These are the parts of theta. That means x plus y is theta. It is obvious that x plus y is theta because x and y are the parts of theta. Now tangent of one part, so say tangent of x is m times tangent of the other parts, that means tan y. So now take tan y to the denominator of the left hand side. We can write tan x is upon tan y is equal to m upon y. And now we will use componendo and dividendo. Using componendo and dividendo, we get what we get. We need here m plus 1 upon m minus 1 on the right hand side. Accordingly, we will operate here. So on the right hand side, what I want is m plus 1 over m minus 1. Similarly, on the left hand side, m plus 1 means numerator plus denominator divided by numerator minus denominator. The same operation I will have to use on the left hand side. So it will become tan x minus plus tan y divided by tan x minus tan y. Now, what we are to do? Now, use this tan x as sin x upon cos x. This is sin y upon cos y. Sin x upon cos x, sin y upon cos y. So what you will get? Sin x upon cos x plus sin x, sin y upon cos y divided by sin x upon cos x minus sin y upon cos y is equal to m plus 1 over m minus 1. Take LCM from the two terms of the numerator and take LCM of the two terms in the denominator. Both the LCM will be same, cos x, cos y, so they will be cancelled out, and you will left with, here you will left with sin x cos y plus cos x sin y divided by sin x cos y minus cos x sin y is equal to m plus 1 over m minus 1. Now this sin x cos y plus cos x sin y, this is the formula for sin x plus y. So you will get sin x plus y in the numerator divided by, similarly in the denominator there is a formula for sin x minus y is equal to m plus 1 over m minus 1. And now the final step. The final step, what you are going to get, this is x plus y, and x plus y is theta. So it is sin theta is equal to m plus 1 upon m minus 1, and this term sin x minus y, I am taking it to the right hand side by cross multiplication method, and x minus y is the difference of x and y, and difference of x and y is given to be phi, so it is sin phi. So you will get sin phi on the right hand side, and this is the required result to be obtained. So next question after that, I am going to take another very interesting question. So what the next question is? Next question is, I am having the statement with me. So first I write the statement and then we will solve it. The next question, what I am having with me is, if 2 sin alpha upon 1 plus cos alpha plus sin alpha is y, then show that 1 minus cos alpha plus sin alpha over 1 plus sin alpha is also equal to y. This is the result what we want to obtain, and this is given to us. So in the solution, I'll start with the required result. It is 1 minus cos alpha plus sin alpha divided by 1 plus sin alpha. This term is given to us, and what we want to prove that this is equal to y. Y means this term. If I want this equal to y, y means this, then what I need in the denominator is 1 plus cos alpha plus sin alpha. So what I will do, I will multiply and divide this term by 1 plus cos alpha plus sin alpha. So this term I am going to multiply and divide it by 1 plus cos alpha plus sin alpha. I am multiplying by it, I am dividing by the same, 1 plus cos alpha plus sin alpha. Numerator I will solve. I will take this 1 plus sin alpha as a, this 1 plus sin alpha as a, and this cos alpha as b. So what you are getting here is a minus b, and here it is a plus b. And you know that a minus b into a plus b is a square minus b square. So it is 1 plus sin alpha square, that means a square, minus cos square alpha, that means b square. Denominator I am not going to solve because this term as it is I need. So I am writing it as 1 plus sin alpha in one bracket and 1 plus cos alpha plus sin alpha in the other bracket. Numerator I will have to solve. In the next step what you are going to get is 1 plus sin square alpha plus 2 sin alpha. That is a square plus b square plus 2ab, and this is minus cos square alpha divided by 1 plus sin alpha into 1 plus cos alpha plus sin alpha. Now you look at this 1 minus cos square alpha. This 1 minus cos square alpha is sin square alpha. So this 1 and this minus cos square alpha is sin square alpha, and there is one more sin square alpha. One sin square alpha here and one sin square alpha coming from this 1 minus cos square alpha will become 2 sin square alpha. So 2 sin square alpha plus this term 2 sin alpha divided by 1 plus sin alpha 1 plus cos alpha plus sin alpha. Now what you will get? You will get 2 sin alpha common. So 2 sin alpha is common from the numerator. 2 sin alpha is common. 2 sin alpha is common, and you will get sin alpha plus 1 divided by the denominator is same, 1 plus sin alpha into 1 plus cos alpha plus sin alpha. This 1 plus sin alpha is cancelled out, and you are left with 2 sin alpha over 1 plus cos alpha plus sin alpha, which is nothing but given as to be equal to y. So this is equal to y, and this is your right hand side which we want to prove equal to. So this is another good question on trigonometry. And now I'll take some more questions, and the next question is, I think, more interesting than this one. The statement of the question is, if I'm writing the statement of the question first, if m sin theta is equal to n sin theta plus 2 alpha, then show that tan theta plus alpha into cot alpha is equal to m plus n upon m minus n. This is the result we want to obtain, and the proof is once again easy. I am starting with the given. What the given is, m sin theta is equal to n sin theta plus 2 alpha. I am taking this n to the denominator this side and this sin theta to the denominator other side. So first I am writing the right hand side, so this is coming out to be sin theta plus 2 alpha, this one, and divided by sin theta is equal to, here I am getting m and divided by n. Now it is very much clear that I am having here m upon n, and what I want is m plus n upon m minus n, which can be easily obtained by using componendo and dividendo. So I am using componendo and dividendo now. Using componendo and dividendo, we get, first I am going to write the right hand side. I am going to write that m plus n over m minus n, what I require here, and accordingly I will operate on the left hand side, and it will become numerator, that means sin theta plus 2 alpha, plus denominator sin theta divided by the numerator sin theta plus 2 alpha minus sin theta. Now you are having sin A plus sin B, or you can say sin C plus sin D divided by sin C minus sin D. So apply the formula for that. Sin A plus sin B is 2 sin A plus B, that means theta plus 2 alpha plus theta divided by 2 sin A plus B by 2 cos a minus b by 2. Theta plus 2 alpha minus theta by 2. And in the denominator, it is sine a minus sine b. So it will be reversed now. 2 cos theta plus 2 alpha plus theta divided by 2 sine theta plus 2 alpha minus theta divided by 2, and on the right hand side you are having the same term, that is m plus n upon m minus n. This 2 will be cancelled out. Here theta positive and theta negative will be cancelled out. This theta positive and negative will also be cancelled out, and you will be left with sine. Now look at this term. This is 2 theta, theta plus theta, 2 theta plus 2 alpha divided by 2. So 2 will be taken out and will be cancelled. You will be left with sine theta plus alpha. And this is cos 2 alpha by 2. So cos 2 alpha by 2 is cos alpha. In the denominator, this theta plus theta is once again 2 theta plus 2 alpha by 2. So it is cos theta plus alpha, and this is 2 alpha by 2. This is sine alpha is equal to m plus n over m minus n. And the final step I am not going to write. It is very much clear that this sine theta plus alpha upon cos theta plus alpha is tan theta plus alpha, and this cos alpha upon sine alpha is cot alpha is equal to m plus n upon m minus n. So the final result is arrived. So we have proved this question as well. So after this I am going to take another very good question on trigonometry. So as I discussed in this video and the coming 2 videos, we will be solving more and more questions on trigonometry. So another question I am taking here. If the question is, first of all, I am going to write the statement of the question. If cos alpha plus beta is equal to 4 upon 5, comma, sine alpha minus beta is equal to 5 upon 13, then find the value of tan to alpha. This is the question. So I am going to solve this for you. Solution of this question now. Look at, first you are given that cos alpha plus beta is equal to 4 upon 5. So consider a right angle triangle. So I am considering this triangle. This is your right angle, and this angle I am taking as alpha plus beta, and cos alpha plus beta is 4 by 5. We know that cos is base upon hypotenuse. So this is base, this is your hypotenuse. So this is 4 and this is 5. It is a right angle triangle. So you can apply the Pythagoras theorem to find the third side. So third side is square root of hypotenuse square minus base square. So it is under root 25 minus 16 under root 9. So it is 3. So the third side is 3. Now you know the base, you know the hypotenuse, and you know the perpendicular. So from this triangle now, we can calculate the value of tan alpha plus beta. So tan alpha plus beta. Tan alpha plus beta. Tan of the angle is perpendicular upon base. So perpendicular here is 3 and base is 4. So this will come out to be 3 upon 4. So one of the values tan alpha plus beta is with us. Now I am going to the other part. So once again I will have to consider the triangle. I will have to consider the property. So here sine alpha minus beta is 5 upon 13. This time I am taking this angle to be alpha minus beta. In this right angle triangle, right angle at this angle, this is alpha minus beta. So this is again perpendicular, this is hypotenuse, and this is base. And sine alpha minus beta is 5 upon 13. We know that sine of the angle is perpendicular over hypotenuse. So perpendicular is 5 and hypotenuse is 13. Now we have to find the base. The base, once again, we will apply Pythagoras theorem. So it is 13 square minus 5 square. That means 169 minus 25. That means 144, and that means 12. So base of this triangle is 12. Now we know the hypotenuse, we know the perpendicular, and we know the base. For this angle now, what will be the value of tan of this angle? So tan of this, tan of alpha minus beta. Tan of alpha minus beta will be now perpendicular or base once again. Perpendicular is 5, base is 12, so it is 5 upon 12. So it is 5 upon 12. Now we have the values of tan alpha plus beta and tan alpha minus beta. Now these two values are with us, and we have to find the value of tan 2 alpha. This tan 2 alpha, I can write it as tan alpha plus beta plus alpha minus beta, because plus beta and minus beta will be cancelled and alpha plus alpha will become 2 alpha. Here we can apply tan x plus y. Tan x plus y is tan x plus tan y upon 1 minus tan x tan y. So I am applying the formula. So it is tan x means alpha plus beta plus tan y means alpha minus beta over 1 minus tan x means alpha plus beta, tan y means alpha minus beta. And now substitute their values. So tan alpha plus beta is 3 upon 4. This is 3 by 4 plus tan alpha minus beta is 5 by 12. 5 upon 12. 1 minus, once again, it is 3 by 4 into 5 upon 12. And now it is just calculation work. So numerator you will add, it will become 9 plus 5, 14 upon 12. 14 upon 12, and in the denominator you will get 48 minus 15. 48 minus 15 is 33 upon 48. 33 upon 48, so it will become 14 upon 12 into 48 upon 33. It will be cancelled 4. So 56 upon 33 will be the value of tan 2 alpha in this case. So it is the value of tan 2 alpha when given the values of cos alpha plus beta and sin alpha minus beta. So such questions may be a little bit tricky, but not too much, because it is very much obvious that 2 alpha is the sum of the angles alpha plus beta and alpha minus beta. So I am moving now on to another question. The next question is, if a plus b plus c is pi, then prove that tan a plus tan b plus tan c is equal to tan a, tan b, tan c. So we will move on to the solution once again. Here we are given that a plus b plus c is equal to pi. So we can write a plus b as pi minus c, taking c to the other side, and now take tan on both sides. Taking tan on both sides, applying the formula for tan a plus b on the left hand side, we will get tan a plus tan b over 1 minus tan a tan b is equal to, and tan pi minus c, it is in the second quadrant, and in the second quadrant tan is minus negative, so tan pi minus c will become minus tan c. And now put it over 1, cross multiply, you will get tan a plus tan b is equal to minus tan c plus tan a tan b tan c. Take this minus tan c to the left hand side, it will become tan a plus tan b plus tan c is equal to tan a tan b tan C, which is our required result to be proved. So this is another type of questions in trigonometry. There are so many types of questions in trigonometry. From question to question, methods varies and many types of questions are there in trigonometry. One more such question is here I am taking. This question is, if alpha beta be such that, if alpha beta be such that 0 less than alpha minus beta is less than 2 pi, sine of alpha plus sine beta is equal to 11 upon 60, cos alpha plus cos beta is equal to 12 upon 13, then find value of cos alpha minus beta by 2. This is another question, another type of question you can say. So once again we will move to the solution. First of all, what we will do, we will square and add these two. Squaring and adding these two, what you will get? First square this. You will get sine square alpha plus sine square beta plus 2 sine alpha sine beta plus, now square this. It is cos square alpha plus cos square beta plus 2 cos alpha cos beta is equal to, on the other side, square of this, 11 upon 60 square plus 12 upon 13 square. Now this sine square alpha plus cos square alpha, it is 1. This sine square beta plus cos square beta, this is again plus 1, plus from these two terms, this and this, take out 2 common. After taking 2 common, what you will be left with? Cos alpha cos beta plus sine alpha sine beta. And we know that cos alpha cos beta plus sine alpha sine beta is nothing but cos alpha minus beta is equal to, on the other side there is simple term, you can square, you can add, and whatever the numerical quantity will be there, suppose it is A. So A is a numerical quantity which is equal to this one. I am not going to solve it in detail because it is just a calculation work. I don't want to waste time. You can solve it. And now this 1 plus 1 is 2 and this is 2 cos alpha minus beta. So 2 is common. You will be left with 1 plus cos alpha minus beta is equal to some numerical value A. And this 1 plus cos alpha minus beta, you know that it is equal to 2 cos square alpha minus beta by 2 is equal to A, the numerical value, whatever it will be. Take this 2 into 2, 4. On the other side, you will get the value of cos square alpha minus beta. So cos square alpha minus beta by 2. This term is going to be equal to A divided by 4. And now what you have to take, just take positive square root on both sides. So I am taking positive square root. So positive square root, square will be cancelled. On the other side, you will get under the root A upon 2. And whatever the value of A, the numerical value of A, whatever you have obtained for it by adding 11 by 60 whole square plus 12 by 13 whole square will be there. And you will get the value of cos of alpha minus beta by 2. So it is another type of question. I am going to stop this video here. In coming 2 or 3 videos, we will solve more and more typical questions on trigonometry, and more of the questions in the coming 2 or 3 videos will be from previous IIT examination question papers. These will be a little bit typical but are really very interesting questions. So leaving you here. I would like to thank you for liking my videos, for sharing my videos with, especially with 10 plus 1 students and those preparing for IIT, JEE or other competitive examination, and subscribing my channel. Thank you once again.